Now, wrapper classes might sound pretty cool, and they are, but this is not going to be a lesson on how you can become the next Chance the Rapper. I apologize, I don't have the skills to teach you that. But what I do have the skills to teach you is the concept of being able to take primitive data types and treat them like objects. Also pretty cool, right? So the idea here is that we want to take this concept of objects and now connect it back to Unit 1 where you were learning about primitive data types. Because ints, doubles, and booleans are useful by themselves, but you'll find that there are also times when you wish that you could treat them like objects. And it might be nice if you had methods that were actually associated with some behaviors or abilities that came with those data types. So wrapper classes are essentially classes that are written in Java so that you can store a primitive value and wrap it inside of a class. And today you're going to see a little bit of the details of how you use those classes. Today we will be learning about wrapper classes. So wrapper classes are essentially the connection between primitive data types and reference data types. So in this unit, Unit 2, we've been focusing completely on reference data types or class types. But in the first unit, we were talking mainly, almost exclusively about primitive data types, ints, doubles, booleans. Now we're going to make a connection basically between ints, doubles, and booleans and class types. Because there are certain situations in Java where you may want to treat a primitive data type like a class data type. And so for each of the primitive data types, there's actually a class in Java that can be used to wrap that information in a class type. So for lowercase double, we have capital D double. This is the double class, can wrap primitive data. And then capital I integer is the wrapper class for ints. And you've actually seen these classes before. You may remember that in Unit 1, we were talking about the maximum and minimum values that are possible in a double or an int. And those constant values, the max and min, are actually stored inside these classes. And so you actually saw these back in Unit 1, but we didn't really talk about how they can be used as wrapper classes at that point. We only talked about how we can use them to access those constant values of the maximum or minimum value that can be stored in an int or double. So let's talk about integer for a minute. This is the wrapper class for an int value. And if you look at how it's used down here, you basically want to declare, like we would any other reference type, integer, give it a variable name, set it equal to a new integer, and then in parentheses here, you pass in the int that you want to wrap as an integer. So just like we talked about in every other lesson in this unit, this is calling the integer constructor, and you're constructing an integer object. And then here we do the same thing again to create a second integer. And then now that we have these two integer types, we can use some methods that come with the integer class. One of those examples is called Compareto. And when a class is able to use the Compareto method, this is called implementing comparable. Because again, if you think back to earlier in this unit now, we've actually seen Compareto before. We've seen it when we used Compareto to compare two different strings. And Compareto for strings told us which string came first alphabetically. Compareto does the same thing, but for integers, of course, it's going to tell us which number comes first. So we're going to take a minute and look at how this actually would perform in code so that you can practice writing along with me. Here you can see creating the first integer, n1, which equals a new, call the integer constructor, pass in 45, and then we do the same thing with 56. And then here we print out the value that was returned by calling n1.compareto n2. And so what we're doing here is we're comparing n1, which is 45, to n2, which is 56. So let's try running this code. And we see that we get -1. So basically what Compareto is telling us is that n2 is a larger number than n1. It's not telling us how much larger, but it tells us which one is larger, and you'll see, or we'll talk about later in this class, that compare to method is actually used for sorting numbers in different sorting algorithms. Okay, so what happens if we switch the position of our object calling the method and our parameter? Then we try running our code. This time we get a 1. And then of course, you also might be wondering, well, what happens if they're actually equal? We try running our code and we get 0. You probably predicted that. As I mentioned earlier, we also have a wrapper class for doubles, and it looks like this. So capital D double, we can call it N1 again, and then they set this equal to a new double, and then we pass in this time, instead of passing in an int, we pass in a double parameter so that we can create a new object of the double class. So with both of these examples, we've been doing pretty formal, explicit declarations. But Java actually allows us to cut some corners if we want to, and we'll kind of do these conversions or these wrapping of data types for us if it makes sense to do so. And in our next video, I'm going to go through what that looks like and then talk about some of the things that you need to be careful of when converting between ints and doubles.